Hello, in this video I will show you how to use online interface to generate a bash script that will automatically search for special quasi-random structure within a certain concentration range of two elements. So for an example, let's say my initial structure is strontium titanate and I want to gradually replace the strontium with zirconium, and I can create concentrations, for instance, like these up to 0.9 ZR01, and in each of this concentration I want to run the search for special quasi-random structure with ATAT mcsqs module. So how to do it? First you need to navigate to this site, and you can also get here if you just write simply sqs.com, and it will redirect you here. And once you are here, you need to upload the initial structure file. So in my case, it's this strontium titanate, which I already prepared in a ZIF format. If you don't have the initial structure, you can also search for it within this interface from like three implemented search interface for 3 databases. So you can see how I did this in my previous video illustrating this application, which you can find if you click just on this link, and if I open it, you can see this caption. Okay, so I will not use this option now. I will simply upload the structure, and then I have to select like which composition mode I want to use. So I want a sublattice mode. I need to define how many atoms I want to search for, and then I can change what should be my elements for the sublattice. So I want to replace the strontium with zirconium. This is now not important, and once I set this, I can choose the parameters for the mcsqs search, and let's include triplets as well, and then I can generate the input files. If I did correctly set a binary sublattice, it will automatically detect it, and it will provide this option. If I would set 3 elements, for example, this option will not be available. So let's put it back. And now I also need to turn it with this enable checker, and it automatically gives me all the possible concentrations for the 2 elements except the edge cases, like where the one concentration is 0. So I can either use all of these, or I can remove some of them, or remove all and select only a few. And this is automatically recalculated based on the supercell size. So I can, if I modify it, like increase, now it changed from 12 to 18 possible atomic sites for this sublattice, and it also modified these concentrations. So let's keep it like this, and for the illustration let's only select like 3 concentrations. And after this I have to set certain parameters. So first parameter is total mcsqs search time for each concentration, or like each folder, and after this time is achieved, it will automatically stop the search and move to another possible concentration that has to be calculated. Then there is maximum parallel jobs. So if I keep it like 2, it will parallelly run, in this case, first like these 2 concentrations, and once it's finished it will move to the remaining concentrations. Or if I can keep 3 here, it will automatically parallelly run all these 3 folders. Then this is the parameter for parallel runs from mcsqs within each concentration. So I can keep it like 5, and this is progress in how often it should update the information into console. So let's put it like 3. The search to be quickly done, let's put it like, for the illustration, let's put it like 30 seconds. So the total estimated time of this run should be 1.5 minutes. In the parallel case, it will be like 30 seconds, because all these 3 will run automatically. But I will illustrate it. Let's just now run it one by one. And now I can already generate the script. So then I have 2 options. I can download the script directly, or I can see the full script here, and I can just copy it with this icon. And then let me remove everything from my previous test, and now I have empty folder, so I can create the bash script. So let's call it just SR, and I will insert here all the content, save it and exit with Ctrl S and Ctrl X. And now I have to make it executable with this command, and so it can be run now. And let's already run it. And okay, let's just one thing. The only prerequisites for this script is to have NumPy for Python, and of course to have the mcsqs module from ATAT, which I already has. Also, you can find tutorial how to install the ATAT on this site here, and where you can find a video tutorial or a written tutorial. Okay, so let's go back and let's start the run. In case there is only one atom for certain concentration, then it will automatically reduce the search time to like few seconds, and also the parallel runs to 1, because it doesn't make sense for just one atom to search like for more options for longer times. There are no options. And once it will finish like one concentration, it will move to another, but before it will move to it, it will also automatically convert each bestsqs.out file into POSCAR format. And if you run like a parallel run, so here in this case it will create 5 bestsqs in each folder, so it will also convert them into 5 POSCARs, and then it will select the best run based on the objective function, and it will copy the POSCAR from this best run into a new folder, which is called best POSCARs, and it will do this for each concentration. So you can see this one finished in a few seconds because only one element was here. Then it moved to another concentration where there were already 2 atoms with strontium. So it ran the full mcsqs run for the set 30 seconds here, and it's giving you the information into the console about the best objective function and from which run it is, and also what is like the current time, search time, and the remaining time. And then it after 30 seconds it finished, and it converted all the best SQS into POSCAR and copy the best POSCAR to this folder, where it gave the name of the concentration also to it. And then it moved to the third option, the remaining third concentration, which I set here. So you can see it finished, So if I show you now the folder with this example, you can see there are the created runs from mcsqs in each folder, and here are the POSCARs also, and then there is this folder with all the best POSCARs. So if I open the visualization tool and put them here, you can see how this structure looks like. So I have here the strontium, select type, yeah, it just has similar color in this visualization. So to better see it, let's put it like blue. Sorry, this is zirconium, let's put it like blue. So this is one strontium, then there are two atoms, like the higher concentration, like here, and then like the third one, third option. That I selected in this range. Okay, so I think this is clear, and just to show you also this parallel run option, let's put it like 3, regenerate the script, copy the content again, now I can remove this error, and let's create it again. And if I run it now, it will parallel run all these 3 folders. As you can see here, it started for all of them. So now I don't have to wait until one folder is finished, and then it would move to another folder with the higher concentration. I can just run them at once. You can see the console here. This is the concentration for which this console output is related to. And yeah, this first one was already finished because it has only one atom for the strontium element, and all 3 finished now. So this is another maximum parallel jobs option. Okay, so if I wish to run like the full series for all the concentrations, I would select all of these, regenerate the script, and let it run for a while. Okay, so thank you for your attention, and I hope this new function, this concentration sweep function, will be useful to you also. Thank you.